Okay, so before we start this topic, I would like to know how many of you are .NET developers? All right, cool. And how many of you have worked with machine learning? All right, cool. So you are in a good session. So now, according to various researches and the implementations we have seen so far, computer vision has been quite essential for many businesses, whether it is to detect a defect in manufacturing or checking out the authenticity for the paychecks or saving up lives on the roads by alerting the law enforcement agencies, identifying the reckless driving or somebody's not wearing seat belts and use cases like that. But this computer vision comes with some challenges, or generally machine learning. Now, two of those challenges are quite big. One of them is the technical capability or the learning curve. The second one is the infrastructure capability. Like you need a very heavy machine, and not everybody has got that sort of luxury to build machine learning models. So today we will be looking at how you as a .NET developer can add machine learning capabilities to your applications, not just with sentiment analysis, like building a very basic model, but also we'll see that how you can build problems like how you can solve problems like computer vision by building object detection model and also adding it to your feed in real time, and we can see how we can detect objects by building that application. So before we get into that, I'll quickly give my intro. So I'm Arafat Tehsin. I have come from Sydney, and I'm a Microsoft MVP for artificial intelligence, and I work for EY. If you're interested in learning about what AI can do for businesses in Australia, I run a podcast with the name of Global AI, the podcast. You can listen to it by going to any of your favorite podcast apps. If you come to Sydney anytime soon, and then we run meetups for Azure, so you can come to us and be our guest on that. It's held monthly. If you are interested in building bots and helping developers with the bot tools, then there is a project called Bot Builder Community. It is tailored towards .NET more. So if you're a .NET developer and interested in learning about conversational AI, please join that as well and talk to me about it if you want to be involved in that. These are my social handles. I'm quite active on Twitter, LinkedIn, wherever you want to add me and ask me anything or connect with me, please feel free to do. Now, the agenda, what we are going to see today is around the projection of AI, why we are discussing this topic, why it is so important, how you as a .NET developer can get benefit out of it. Then we'll move to the ML.NET and we'll see that what problems ML.NET can solve. Is it just too basic to solve very basic problems of machine learning, or it can really build something like recommender systems. Then we'll talk about the tooling, which is CLI, how CLI can help you, and how I built a library that is downloaded roughly about 17,000 times just by using CLI, ML.NET CLI. And we will, in the last, we'll see model builder. So this is one of the latest offerings by .NET framework, like .NET team. And they have created a GUI tool to build all of that in one window. We'll see how we can leverage the power of Azure as well to build all of these models. So in addition to this, there will be, so I've got some swags available for you because my sample data is all about swag. But I have one of the bags full of swag from Microsoft Build. So I'll ask one question in between, and whoever gives an answer first will win that. So it is as simple as that. I would like to start my talk with this quote, and it's not just a vision of Microsoft. It's the vision of many other, even small startups who are trying to democratize AI by allowing everybody to create solutions with the technologies and with the technologies like AI and solving those problems. Now, this has been a challenge that right now, if you want to build some sophisticated machine learning models, you need to have only certain capabilities to build that, such as you need to have a knowledge of Python, which is quite famous in that. But Microsoft and other players are working towards that. And because of this, we will talk about the projection. So because of this, you can see the value it is going to create by 2030. When retail is booming right now with AI-infused solutions, what it would do when it reaches 2030. The rate of automation will increase from 33% to 47% just after 3 years. And the rate of manual work will decrease from 53% to 67%, and humans will be able to focus more on what is more important rather than working on the repetitive tasks. Now, this will never work. This will never come in just 1 day, 2 days, or it can never happen over the night, or even within some years. It is going to happen in some next years, but it has started happening now. How? As I spoke about the infrastructure capability or the infrastructure limitation, that you need to have certain machine, certain power or resource-intensive machine that can create machine learning models. So as not everybody has it, and you really want to build those models from your machine, so the cloud providers saw this as an opportunity, and they created cloud AI developer platforms like Microsoft Azure has created Azure Machine Learning Studio and things like that. Google has created Google AI, and Amazon with SageMaker and many other companies. So this is where everybody is heading to, and it's not like, yes, they are leaders, but there are others who are following them. So this solves just one problem of infrastructure. It does not solve the problem of the capability side or the learning curve side. Like, you still want to use the stack which you love, or the stack which is your primary stack. Now, if you want to create some machine learning stuff, you want to do that, but with the limited, or with the like you don't have enough time to learn about it, and yet you want to create some sophisticated models. So how can you do that? And this is the second part of it. So these leaders thought about it and also came up with another strategy of creating no-code, low-code AI tools. So if anyone of you were in the keynote today, Richard Campbell showed the Power Platform. So it was just because that the companies or the businesses are going towards that they want to allow everybody, or who's near to the business users, can create those solutions. And that's how the no-code, low-code AI landscape is also working. So if you see these tools which are available, you don't need to be an expert in any of these tools, whether it is Azure ML, Google's Dialogflow, you can create Amazon Alexa's skills and Google Actions without writing a single line of code, and yet it can be sold to businesses. According to Gartner, by the next year, many enterprises will have low-code applications installed into their environments, and whether it is leaf tracker, whether it is expenses, HR apps, but you can still infuse AI capabilities into those applications. And while I was looking at it, I had a look at the Google trend, that what it was going and what people are looking for. So interestingly, I found out that a lot of people are looking for no-code, low-code solutions, and that's how the trend is going upwards. Now, let's talk about what is ML.NET, because we all are .NET developers over here. So before we get into that, let's have a look at Microsoft AI stack. So this stack shows the Microsoft's capability, but it also tells you that you do not need to be an expert in order to create machine learning stuff for your own applications or for your own customers or businesses. If you see the level of knowledge which is required, starting from Azure ML Studio to ML.NET or to even AI Builder, it is literally beginner to intermediate. And if you're a developer like me whose primary job is mainly around .NET or the Microsoft technologies, then you may want to end up at ML.NET or cognitive services if you are primarily working with .NET. And some stuff can be done on Azure ML, which of course cannot be done on cognitive services because it's just an API on the AI on API. Now, let's talk about ML.NET specifically. So, a little bit of history. In 2002, Microsoft researchers started implementing AI capabilities into their own applications. Fast forward 2011, they combined those capabilities into one library called the Learning Code. TLC was then made .NET friendly, open source, cross-platform, and released it in 2018 as ML.NET. So ML.NET is an open source and cross-platform machine learning framework for .NET. It's an offline first of all, so you do not need an Azure subscription to create any of those models. You can create your models directly on your machines. It can be hosted on any cloud, as well as it can be hosted on-prem and on Azure as well. Now, why do you want to use this? So as I said, we all are .NET developers. So if you want to stay in this ecosystem, or your primary task is not heavily involved in machine learning stuff, yet you want to create some basic capabilities of machine learning. Just giving you an example, like you want to predict some classes where your next customer, or what will be your next customer's action, in which category your next customer will be spending on if you are building financial solutions. And you can, if you want to train the existing model as well. So let's say if you have got a TensorFlow model, you want to use it within .NET, you can use through ML.NET as well. Now, what are the possibilities that ML.NET can solve right now? What are the problems? So it nearly solves pretty much everything that is involved within so many businesses. So from classification, which is about A or B, true or false, eligibility or non-eligibility of a customer, will this customer buy your thing or not? Regression, predicting the prices of your house, forecasting, anomaly detection, you're detecting the temperature in your data center, or checking out the quality of air and things like that. Then we have got recommendations, ranking systems, and image classification, like identifying an image from by giving an image and identifying that what kind of image it is, and then detecting an object, which is our topic today. Now, what tools do you have right now? So you have ML.NET API. When you install Visual Studio, let's say, that comes built in for you. But on top of that, you have got AutoML API. So what is AutoML API? We'll talk about it in a bit. And on top of that, like on ML.NET, we have got ML.NET CLI and Model Builder. So ML.NET CLI and Model Builder both are using AutoML.NET API. Now, before we get into AutoML part, let's understand the basic machine learning workflow. And it is a very, very high level machine learning workflow. So you just prepare your data. You prepare the data where let's say you want to predict the house prices. So you want to have the data which impacts the house price, and so you can keep that data for you, and then also define it as a supervised model. So there is a difference between supervised learning, unsupervised learning, and reinforcement learning. We are not discussing that part, but I'm just talking about that you need to prepare your data, clean your data, and then once you do that, you pass it to the system, and then when you pass it to the system, it builds and trains, and then it generates a model. So the process of building and training and preparing that is called the model creation process. And then the process where you are using that model into your .NET application or any other application, that is called model consumption. So these are just the basic terminologies which I wanted to take you through. Now the question time. We want to solve this problem. How much is this car worth? Can anybody tell me that? What kind of a problem is it? Is it anomaly detection or classification? Yes, please.
Regression.
Yes. So that's correct. I will give you this. Thank you very much. Okay, so this is a regression kind of a problem. And since it's a regression problem, so let's solve this with typical machine learning model creation. Now, you will select some features, and you have some features like mileage, car brand, year make, right? And this is what it is going to impact your car's price. Then we have got algorithms. So algorithms are already present. You don't have to create algorithms. They are already there for regression. They are already there for classification. And they are quite famous algorithms. So we just have to use that. Now, all of these algorithms are regression algorithms. But we chose the first one. And we defined some hyperparameters, like some settings towards that. And we saw a model of 30% accuracy. Now, nobody wants to use 30% accurate model, not even you. Even if you are a developer and building for yourself. So if you want to improve this, what you have to do, you want to increase your features, maybe, right? You increase your features, you change the algorithm, you define the hyperparameter, and you get the output as 50%. Now, if you want to increase it more, you need to play around it, and it's quite an iterative model. So until you get the best model, you have to do that, sadly, again and again. Yes, your experience will define it, but your experience cannot define it for the first go, in the first go, second go. You may take some time to learn about these things. Now, wouldn't it have been better if we had machine to do this? So we'll just define our goal and inputs, and then machine would learn, intelligently run parallel, like it will create parallel models, and whatever the highest accuracy model it will create, it will just generate that as a model. So that's what AutoML is all about. With AutoML, we do not have to do the selection of algorithms, hyperparameters. It does it automatically. Can you change it later on, or can you define it forcefully that you just need to use these algorithms? With code, you can do that. But without code, you cannot right now. Now let's talk about ML.NET CLI. So as I said, that CLI was also built on top of AutoML. So it is quite easy, and it's cross-platform. You have Mac, you have Linux, you have Windows. You just install the package and then create the model by writing simple commands. And that is also available on GitHub. So their samples are there, and we'll see that in a demo. The good part of this is it not just creates the model, but it also generates the source code and the examples that how you can create those, how machine has created that for you. So everything is there. Now, what I was talking to you about, that how I built a library. So I built something called sentiment analyzer. What it does, that if you give a sentence to it, it returns you the sentiment of that. So if I'm writing that I love doing this, it's a happy sentence. And if I like that I don't like you, it means that it's a negative sentence, so it would return 0 or 1. And it was quite simple, and I just built it at that time. I never knew that it would be used that much amount of time, but luckily everybody started using it, so I moved it to a new repo, and I've purposefully have created an enhancement, which I will show you. And if you want to contribute to it, you can, of course. So let's have a look at the demo first. So this is how you install your ML. Sorry, my mouse. Yes. So this is how you install your .NET CLI. So I'll post all the links, but you can just literally go over here and download this in your terminal. So I've got a terminal open over here, so I will just yeah, that's my terminal, and I will just show you how we can create this. So first of all, I'll show you that I've got this already installed. So if you see the last one, ml.net, mlnet win x64. Now, if you want to create the classification model, we will just go to our data set, right? And this is my data set, right? So if I open it up, you will see, sorry, let me bring this over here. So you will see this this file. So this file is quite simple. It has got some utterances, some tweets, some I've taken that data from IMDb and Twitter. So this is publicly available. You can download this as well. This is the utterance or the sentence, and this is the label. Label means that whether it is true or false, and it is correctly labeled. So if we give this information to machine to create a model, so what it would do, that it would create a model, and when you pass your sentence to that model, it will predict on the basis of this historical data. So now let's see how we can build the model with this. So this is the simple command. You can, as I said, that as I said that this is a part of machine learning sample. So you can go over here, get the same command over here and start using it. So I'm using a slightly different command, but because of my nature of the data and what I'm passing towards, because I don't have a label. So my label column is 1. I do not have header. My training time should be 10 seconds. So I don't want to increase the seconds. And if I run this, what will happen is it is going to create or go and start running the machine learning process. So you can see that AutoML is trying to use some algorithm. Now it has started using 2 algorithms in 10 seconds because, or in fact, it used 3 of them. Now it has used 3 models, and out of that, it found out that last one had the first one had got the highest accuracy. Sorry, the last one. So it generated the model with that. Now where it is residing? So if I do ls, you will see a model has been created over here. Sorry, not the model, even a sample project as well. So I will just bring that window to you so that you can see. Okay, so this is the model which it has created. Now, if I go and click on this project and open it up in Visual Studio, so you will see that this is purely created by AutoML. We have not done anything. And how it is created, it has also created mbconfig file, which I'll walk you through, but it is expandable. So you can see that everything is generated by machine. I did not do anything, right? So what it is using, how it is using, you can see that, and everything has got a documentation involved. So ml.net was released first, AutoML came second, and if you want to do controlled development of machine learning models, you do not have to really use ml.automl. You can easily go and start using ml.net directly. And in fact, you can also modify this code. So we will just run a test of it. I'll just comment this code because this is redundant over here, and I will say that I am now. On the basis of this, it should give us some response. Now it can give, if the data is trained badly, then if the data is trained badly, then it would give you a negative response. But if the data is correctly present and the model is trained correctly, then it would give a positive response because it was a positive message or it was a positive sentence, right? So this was about the sentiment analysis, and because of that, as I said, what I did was, let me just go to my repo again, sorry. So what I did was, I open sourced this library, so you can go, sorry, oh wow, the internet is not working, but that's fine, we'll connect it. Just give me a moment, please. It should connect. Yes. So if you go to this library, you can have a look at it. Yes. And I mentioned that I've created as an enhancement, so you can go and check it out, and you can start building this. Anyway, let's talk about the next stuff, which is this. So as I said, that sentiment analysis is not the end of the world. So we have to create something meaningful. Yes, sentiment analysis is meaningful, but it is just solving one problem. Let's talk about model builder quickly. And model builder, so it's a no-code way to build custom machine learning models. You just have literally the GUI. You don't need to write code yet. If you want to write code, you can do that as well. But it gives you an opportunity to create the machine learning models without writing any line of code and solving problems. So this is the difference between machine learning, image classification, and object detection. So because some of the people normally confuses themselves by considering it as same problem. In image classification, you are just identifying an image and labeling it as one label. However, in an image, if you want to identify an object in an image, it can identify by locating the objects in the frames. Now, as I said, that model builder solves all kind of problems, so it is this, but let's first talk about tagging. So now you want to detect an object, but how would you tell the machine that this is A, this is B, this is cat, this is dog, this is train, this is plane, if you want to detect that? So for that, you need to have a tool for this. Azure Machine Learning Studio already has got a tool online, but we are not talking about Azure right now, and we are talking about ML.NET. So for this, we have got a tool called Visual Object Tagging Tool. VOTT was created by Microsoft's commercial software engineering team for their own work, but they then open sourced it. If you go to this repo of GitHub, you may see that it is archived now recently, but don't worry about it. You can still use it. You can still create the target files from it. You can still import it. It will work as fine as it was working earlier. The reason I think they may have done it because of in the interest of Azure maybe, but if you even go to the ML.NET docs, they are still referring VOTT. And I spoke to one of the ML.NET product managers, and they confirmed me that it is like they are not doing anything, or they are not archiving it for now. Like you can still use it. Okay, so let's have a look at the demo now. So I will walk you through first. So before we get into the VOTT part, let's quickly build the model, because model will take some time, and then we will talk about tagging. So this is the application. You can see I'm creating a console application with the name of NDC ML console app. And I will show you that how you can use model builder easily. So my apologies, it has created over here. So, okay. You just have to click. By the way, you may want to download model builder as an extension if your Visual Studio does not give you as built-in. So this is the model builder for 2022. I'm using Visual Studio's preview version. So it has got some of its issues right now, but it will work for GA versions or preview or anything, any version of Visual Studio 2022. Now let's talk about this. I will go over here and add a file machine learning model. I won't change the name of it, I will just add it. So once it is added, you will see that it has given us many options. I will choose object detection model, but if you go over here, you can see that this model can be created locally, this model can be created locally, this model can also be created locally, and it requires Azure, like you can do that in Azure as well. Sadly, object detection is a very resource intensive operation. So to training, not the object detection per se, but the training of that object detection model. So you need to have some good amount of resources like GPUs to train this model. That functionality should be coming hopefully soon somewhere, but right now there is no information on that. So you need to use Azure. When you click on this, you need to set up a workspace. And we will set up a workspace, and it will try to give me some random errors, but don't worry, we will still create it. So it sometimes happens that it tries to give us, I'm using Visual Studio 2022 preview version, so it sometimes happens that it gives us few errors, but we will be able to create it. So depending about how best the internet is working. Let me see if it has given me anything wrong. Yes, so it has started giving me errors, right? So this is good. We'll just cancel it and it will be fine. So, oh my God. What is going on? Oh, let me just close these windows, and we will work through that. So I will close this because we don't want to use this. Okay, I will. Not sure. Can I open the other one? Okay. We'll try it one more time, but let's see how it goes. Yes. Okay, fine. It has started giving me these errors again. Please work. Please work. So it is still cancel, like running. I do have a model created, so if it doesn't work, we will still have a chance. Don't worry. I keep backups. But yeah, just checking one more time. I think it's because it looks like it's no. Yes. Let's see if it loads. Can I? All right. So this is the machine learning workspace you need to create. You can create directly from here, or you just have to name the model. So I'll just name the model as or experiment. So you need to create an experiment in Azure Machine Learning Studio. It will create directly from here if you do not have it from there. I already had created it, so that's why it is showing me. Now next step, you will have to choose the file where I was telling you about the object detection target file. So I will show you where exactly it is. So and then we'll talk about once it is building, we will talk about that. So what we are trying to find out is we are trying to find out trying to detect this swag. So I've got some stickers. I can give it to you as well for you to try on. So we are trying to detect these. That's what kind of stickers are these. So you can see that this is Bot Builder and Azure ML. If you say these are different data, so you will see that cognitive services and Azure ML. So we'll just say next and start training. So once we start training, it will also generate a URL for you to see how it is training in Azure, and I'll take you to that URL once it gets generated, and then we'll talk about so it will never work over here, but because I'm not logged in that profile, I will try to log in within my profile. So yeah, and I'll show you. Okay, so bringing that here. So this is my Azure Machine Learning Studio, right? And if I go and click on it, you will see that it will take you to the experiment which is being trained. It will take some time. How much time? Nobody knows. The rough time is mostly around 10 minutes, but since we will not wait for that, so let's talk about the object detection model, and meanwhile we'll see if it gets done. So how the object detection works. This is the tool which I was talking to you about. You just have to create a project over here. Before you do that, you have to create a source. So we'll quickly create source, and we'll try to label flowers. So I will say source flowers, and I will define it as my local system. So this is my local system. Now in my model builder, these are my source. So this is my source folder, and then I'll define a target folder. So target flowers, and then I will go over here and also choose my target folder. So maybe my target folder is not there yet. We will create it. Target flowers. Fine. Now once you create it, you can create a project, and you can define that this is your. So I will name this as NDC flowers, and choose my flowers token, my source flowers, my target flowers, and I can define my tags over here like rose, daisy, and whatever the flowers we have. So if I click on this project, you will see that there are a lot of some flowers in my folder. Now I can start tagging as this is rose. Then I can start, so this is tulip, but we do not have the tag for that. So I can go over here, create a tulip tag, and then start tagging it as tulip. And same goes for sunflower. We don't have the tag for this, so I'll just create a tag for sunflower, and then we will tag this. Now I don't want to tag all of this in front of you to bore you, so I'll just click on export, and I'll show you that this file, the JSON file which I was talking about, will be created in this folder of my model builder. So if I go into the target flowers, you will see that this is a JSON file which I uploaded. Right now, since I created the swag folder. So I would like to show you that. So these are some of the tests which I did when I was creating my data, right? So this is Azure ML, things like that. Everything is done. Model is, let's say I've created the model. In the interest of time, while it is being created, while it is being still provisioning the compute, I will show you what I already have it. So now, as I said, we would build real-time object detection model. So what we would do is, I'm using Universal Windows App, UWP app. Many people may ask that why you are not using .NET MAUI or WinUI 3 or WinUI 2. The reason for this is MAUI or the WinUI do not have sophisticated media APIs right now. They still are lacking behind in that. So they are having only camera API, which you can just use to take a photo, but you can't capture the frame out of the video, right? So that's why we will be using it. So now if I run this, you will see that it will just open up my camera, and the main goal of this is to create the labels when I put something on it, like when I put, let's say, this or this. But right now it is not doing it. And how I am doing this is very basic stuff. This code is quite available everywhere, but I'm taking out the camera preview. So this is for those who have worked on XAML or Xamarin or .NET MAUI, they can relate it that this is XAML. So I'm using media element in between, and so that's a camera control, you can say. So what I'm trying to do is I'm finding out the camera, and then I'm just previewing it. And for the drawing of that particular rectangle, what I'm doing over here is, let me find out. So yes, so over here when the frame gets arrived, what I do is I create a frame. So if I go over here, I process in the process frame method, I'm just trying to create a rectangle on top of it, and using UI thread. So now it is good that we are able to create that, but we want to do something more, and we want to use machine learning capabilities, right? So let's turn it into an object detector very quickly. So first of all, as I said, that our model is already here. So when this will complete, when this whole will complete, it will generate a model called ONNX model, ONNX, ONNX model. On top of that, it will also tell you how you can consume that. ML.NET will give you that code. So I've taken that code over here, modified a little bit. When I say modified, because I'm using, in order to consume this in your Windows applications, you need to use WinML. So WinML is a Windows machine learning framework which you can use to use those ONNX models into your Windows apps. So I hope that it would be available in .NET MAUI, or at least in WinUI 3, which is going to be awesome. If it is not, then we may have to see that how you can use just a mere ML.NET to sort this thing out. But you can still use ML.NET, just ML.NET to work around this. Anyway, let's quickly change it to, so I'll add some so I have some boilerplate code. I'll quickly add and I'll explain, and then we'll see how it actually works. So over here in my ML stuff, I'm loading a model, right? And this model is nothing but this file, this swag model file, right? And what I will do is I will just go over here and write. Okay. Now, for this, we need to capture that, and we need to capture that somewhere. So my idea is when a frame gets arrived in your like when you receive a frame in your application, like where we were drawing the rectangle, I would pass that frame to a machine learning model, and it would detect what object it is and where it is located in the screen. So it would draw the image on that screen, or on that side of the screen, or on that side of the image. So this was my video frame capturing. So I'll just comment this code out, and this is how I'm going to use it. So my process output method is not there. I'll just bring that, and then I'll explain my process output method as well. So what I'm doing over here is that when the output comes from the so what I'm doing is I'm using my model. This is the model which I told you. I'm using Windows machine learning WinML. So WinML is, you can easily go to their docs, and you can see that how you can build you can use WinML. So in this model, in this model, what we are doing is we are just giving the data, giving the frame to my model and getting an output of it. Now that output will be passed to my UI thread, and on that UI thread what I'm doing is I'm trying to create a bounding box, right? And on that bounding box I'm also creating a label that what it is identified as an image. So as I told you that I've got some bunch of swag, so we'll see in our demo that whether it can really detect. And over here you can see that box score is more than 0.5. So it means that if the accuracy of that image which I'm going to pass it to the model, if the accuracy of that is more than 50%, then only it would draw, otherwise it would not draw. So because it is there is a chance that it can, like this is Azure functions, but there's a chance that it may detect it as .NET because of my bad training data maybe. So let's see this in action. So it will take some time. Now, by the way, you did not see that earlier, right? So okay. So if I do this, yeah. So that this is what I was saying. So because my training data was having a different background, but if I just, so you can see that if it has now started getting it, and if I bring this as well, it will start identifying it. But the reason why it is getting a little slow because how it is capturing it. So I'm keep on moving it, and you can see that it is not moving with me real time because it is trying to create the binding every time, and sadly the real time binding of WinML is not super fast right now, and that's why it is giving you this sort of experience. However, that's not the case with ML.NET if you are passing directly to ML.NET. So I'm passing it to WinML rather than ML.NET, but my model was created from ML.NET. So this was just to show you that there is a capability to create models, but yeah, ignore that .NET. But if you see this, you will see that this will be detected. So and also, so you can see this, right? And also, I have kept a condition. Even then, it is creating. It is detecting as .NET more than 50%. But yeah, so this was it. But I will show you if it is downloaded. Hopefully. Oh, okay. No, it is not. Meanwhile, it is downloading. If you have got any questions, please you can ask me because it will take some time. Yes.
Yeah. So I'm kind of trying to understand. Tagging is teaching, yeah.
Yes.
So to me, I'm recognizing that, like, I think of an object spatially, and so you see something head on, it looks one way, but you look at it from the side, it looks like another. So if you were to
Yeah. So the question is that if so that's not a very 3D model, but the question is if this bottle is captured or trained from this side, will it be able to detect from this side as well?
Yeah.
Okay. The short answer is not really, because machine will only understand whatever we are going to train it with. And this is in case of supervised learning. So what we have talked about is supervised learning. Like you train the data and you then expect the output of it. So if your historical data does not include any of this angle, it may end up like this, what we were having. Because my training data was more of having a very light background, and I was training it in my room, let's say, whereas we have got some different backgrounds over here, and that's why model predicted like no, this is something else. And in the real world scenario where you are just detecting, let's say, one of the companies in Australia is doing this on a gas stations or service stations over here, that they capture the cars and their number plates using ML.NET. So you can go to Microsoft case studies of ML.NET, you will find that. And they are just capturing the cars, their number plates. So of course there's a probability that the car is coming on this side, car can also come from that side. And so they have trained their model in a way that they have considered all the possibilities. If I had done it, then yes, but you have to explicitly tell the machine to do that. Any other question? Yes.
I know with MLNet we have those standard forms of detection, sentiment analysis, etc. If we were to do something like pose analysis or pose detection, is that possible in MLNet?
Sorry, which analysis?
Pose detection and stuff like that, those extra sort of extensions on ML that's not what you just demonstrated today. Is it possible in ML.NET?
Yeah, I've not seen any use case with that yet. But so what my suggestion would be that there are many models available of it, and what you can do is you can use that model and train on your specific data. This is possible in this is possible in ML.NET. So you can use existing model and you can train it on top of that with your own data. But by default it is not there. Yes, please.
Yeah, so it's a question actually following on that one. So when you say train on top, like I'm thinking on the Apple iOS stuff, for example, you've got the raw machine learning, but then they have models they've already trained, like for example detecting hand gestures.
Yes.
And then you can train your own model on
Yes.
the outputs of that model. Is that what you
Yes.
mean when you say training on top?
Yes. So there are very famous object detection models called YOLO, YOLO. It has got many versions of it, but the latest one, like they are keep on improving. It's like a GPT-3, you can say. So you can take that model and train on top of it. And the reason why you would do that, because it is already fine trained, and you really don't want to end up in a situation like this. But this is good in terms of the service station scenarios where you really want to have just specific objects. You don't want to generalize the objects. So I'll take questions, but let's see in the last over here. So this has been trained. Now, if you see this, it will give me the capability to test it as well. So I'll browse my image and I'll add up any image which was from my background, from my data set, and it has correctly predicted that this is Clippy, the old Office Clippy. So I should have it. Yes, this Clippy, and then it was the Global AI Community sticker. So it has correctly predicted now. The reason why, because I'm giving the same image. This was not the same as a part of training set. It is a part of evaluation data, but it is still the same background. That's why it is detecting it properly. Now, the good part of model builder is it gives you the solutions. It gives you the capability to add it to your solutions. So you can, like, it gives you a sample project. So if I add this console sample to my this project, you can see that it will generate all the code for us. It will create Onyx models for us. So this is the exact same Onyx model which I was using over there with the name of swag model. But it will also give you training that how it has trained. It will also give you a way to consume it. So this output class and this input class was the class which I was using over there in my model. And I want to show you. So if you see this URL, so this is a part of one of the training data. What it is doing, it is creating that, it is taking that file and passing it to the model. And I will just stop it because I want to run the other one, not this one. Yeah. So I will just try to show you this project, that if we pass the image to ML.NET model, it will generate the same stuff, but like it will generate the same coordinates and everything. But since we are showing it on our camera feed, definitely console app cannot do that. But you can see that it has detected Azure ML and bot builder community sticker. So I'll go to that. I'll go to this exact image, and we will see that what kind of a so this is the one. Sorry, it has opened over here. So this is the one. So Azure ML and bot builder community. So you can see that it has detected it correctly. And we just have to pass the file, and you can see the results of it. So I think that's it from my end. But if you have got any questions, otherwise these are the resources. I've written a blog post about it in detail. You can have a look at it. Otherwise, any more questions? No? All right. Thank you very much. But before we do that, so if anybody is interested in having these stickers, please come to me, and I'll give you many of them. So I've got a bunch of them. You can use them for your training and start building solutions like these for your projects. All right. Thanks all.